Yes, you are welcome to full free online tutorial class on how to draw an energy profile diagram. In this video, I'll be showing us the definitions of exothermic reactions, the definition of endothermic reactions, examples of exothermic reactions, examples of endothermic reactions, and then we are going to consider the energy profile diagram of both exothermic reactions and endothermic reactions. This is Olorutoba Kayode. You are welcome to Chemistry Apostle channel. Thank you. Okay, let's go. What is exothermic reaction? An exothermic reaction is a reaction in which heat is liberated to the environment. An exothermic reaction is a reaction in which heat is liberated to the environment. Remember, exo, you can tag with external. Exoskeleton. Heat is given out. Example of exothermic reactions, we have neutralization reactions, we have combustion reactions. Those are the examples of exothermic reaction, and any other reactions that involves liberation of gas. Any reactions that involve liberation of gas is an example of exothermic reactions. I hope you got that. Okay, let's quickly look at endothermic reaction. When we say endothermic reaction, is a reaction in which heat is absorbed. A reaction in which heat is what is absorbed, like endoskeleton, endocrine. Something is inside. Something is what is inside. So an example of endothermic reaction, we have photosynthesis. You know, I said it's a reaction in which heat is absorbed. Look at photosynthesis. Even in chemistry, we say photosynthesis is an example of photoelectric chemical reaction. It's an example of photochemical reaction. Sorry for that statement. It's an example of photochemical reaction. Okay, that is, heat is absorbed. Photosynthesis is an example of endothermic reaction because heat must absorb before the reaction takes place. Likewise, melting of ice. When you put water inside fridge, liquid water, when you put it inside fridge and then you remove it, before that ice water melted to form ordinary water is going to absorb heat from the surrounding so that it converts it from that solid state to ordinary water, and that's a typical examples of an endothermic reaction. I hope you got that. Okay, let's quickly consider energy profile diagram of exothermic reactions and then endothermic reaction. If you look at the screen there, now exothermic reaction, the vertical line, the one that comes like this, the vertical line is the one that shows the chemical energy, and then the horizontal line, the one that bends like this, is the one that shows the reaction pathway. At the first line you have up there shows the reactant, and we have the curve down to form the product. Okay, between the reactant, the one that is up and the one that is down, is what we call the enthalpy change, the heat change of the reaction. And what's the enthalpy change? Enthalpy change is the difference between the heat of the product and the heat of the reactant. So for exothermic reaction, that enthalpy change is negative because during exothermic reactions, heat is liberated to the environment, and the liberated heat is a form of energy. So because of that, the reactant is always greater than the product, and the ideal thing is when you want to get to enthalpy change, you minus the heat of the reactant from the heat of the product, and that gives you a negative value. Because of that, enthalpy change for an exothermic reaction is negative. I hope you got that. Now the second one is endothermic reaction. Energy profile diagram of endothermic reaction also look like that of exothermic reaction, but the difference between them is that for endothermic reaction, the product is up and the reactant is down. So when you subtract the product from the reactant, you are going to have a positive answer with that diagram, and that is why for an endothermic reaction, the delta H, the heat change, is always positive. With that diagram, when you look at that diagram very well, there is a line in between, and that line in between is called activation energy. Activation energy, just energy barrier before the reaction takes place. I hope you understand that. Please do subscribe to my YouTube channel, Chemistry Apostle. Thanks for watching.
I will blow your mind.